Hello, here we have the AQA GCSE Mathematics Foundation. Paper 1 is a shadow paper that was meant to prepare you for November 2021 exam. Because it's paper 1, it's a non-calculator one and you get an hour and a half to do it. Like always, any practice you do is good, it's useful. First question, circle the answer to 0.6 times 10. When you multiply by 10, the number is going to get bigger. How much so? Well, if there's 1 0, the decimal place will move 1 place to the right and you'll end up with a 6 coming out as the answer. If you look at question number 2, it says write the expression that is equal to y, take away y, plus y. Well, if you have something and you take that something away, you're left with nothing. So that first part there is basically nothing, which means we just have a y left over. Question number 3, what is 260 centimetres in metres? So you need to remember that when you changed from centimetres to metres, you have to divide by 100. So we started with 260 centimetres, we're going to divide by 10, divide by 100, so you're going to end up with 2.6. On to question number 4, and question number 4 is asking which of these 4 shapes can have sides with lengths that are all different. Now it doesn't mean it has to, it means it can. Now clearly a square is no good because a square all sides are always equal. And a rectangle is also no good because the left and the right will be equal and the top and the bottom will be equal, and that always is true, so again no good. A parallelogram is a rectangle that's been sheared. What do I mean by that? Well, it's basically been pushed over, which means the top is the same as the bottom and the side is the same as the side, so again no good. Which means we're left with a triangle. And if you're not convinced by that, remember a triangle can have all the sides the same, like in an equilateral. You could have 2 sides the same, like in an isosceles, or in the case of a scalene, you could have all 3 sides different. So it's true that you could have them all the same, all different. That's a triangle, a scaling triangle. Part 5 is asking you to work out what happens when you do 6 times 7. Now the multiplication of 6 times 7 would give you 6 times 6 is 36 plus another 7 would be 42. Okay, but remember you don't have 2 positive numbers here, you have what is actually a positive number multiplied by a negative number, which means that our answer will come out as a negative. So you're going to end up with negative 42 coming out. Let's turn over and look at question number 6. Question number 6 is a calculation question, and here we have, it's a 4-mark question. Louisa buys 3 apples and 4 pears. The total cost of everything together is £3.40. Each pear costs 45 pence. Work out the cost in pence of each apple. So we need to break this problem down. What do we know? We know that there are 4 pears and each pear costs 55 pence. So what you're going to have to do is you can add 55 plus 55 plus 55 plus 55, or in my case I'm just going to say 55 times 4. 4 lots of 5 is 20, carry 2. 4 lots of 5 is 20, plus the 2 I carried would be 22. So it would be 220 pence for the pears. That is how much it would cost for the pears. Okay. Now the total cost was £3.40, but because they want the answer in pence, I'm going to change it into pence, and to do that we will multiply it by 100 to end up with 340 pence. We want to find out how much the apples were. Now the apples is what's left over, so we had a total of 340, and we're going to take away the 220 that we spent on the pears. 0 take away 0 is 0, 4 take away 2 is 2, 3 take away 2 is 1. So there were 120 pence spent on the apples. How many apples? Well, there were 3 apples, so I'm going to split that. So we're going to have 120 split or shared or divided by the 3 apples. 3 into 1 doesn't work, Now if I have 12, 3 into 12, that does work because 3 times 4 is 12. Remainder 0, so 3 into nothing is nothing. So you can see that the cost of each apple was actually 40 pence. Things to remember are changing between pence and pounds, and also just being very careful in your calculations. These are not the only methods for these calculations. Find the ones that suit you, but the answer is 40 pence nonetheless. On to question number 7. Question number 7 is a nice one. It has a pictogram, and they tell us that Sahid counted the pieces of 3 types of furniture he had repaired at his workshop. He draws a pictogram to show the results: table, chairs and sideboards, and they tell us in the key here that each of these diagrams represents 4 pieces of furniture. So part A, Sahid had repaired 7 sideboards. Show this information in the pictogram. So in other words, we're going to have to draw something that's worth 7. So if I draw a full circle and I split it into 4, that's worth 4. I need another 4. But if I draw a full circle and cut it into 4, I'll end up with 8, which is too much. So I actually need only 3 of them. So as you notice, I did what basically is one of the quarters missing, and that would be represent 7. You do that and you got your mark. Part B, Sahid spends 45 minutes repairing each chair. Work out the total time he spent repairing the chair. Give your answer in hours and minutes. So we're going to focus on the chairs, and chairs we have 4, plus another 4 is 8, plus 2, 10. So there are 10 chairs. And they tell us that he does, each chair takes him 45 minutes. So if we have 45 minutes multiplied by 10, because our 10 chairs would give us a total of 450 minutes. Okay, now that is a total time, but they didn't want the answer in just minutes. They wanted to give you answer in hours and minutes. So we're going to have to find out how many hours fit in there. So what you could do is you could basically go counting up. 1 hour is 60 minutes. Another hour would be another 60 minutes, which would add up to 120. Another hour would be 180. Another hour. So you could keep doing that. Okay, that's one method. You could do a division. Okay, but at the moment I'm just showing a longer method. Okay, so basically here we have plus another 60 would give us a total of 240, and then we'd have another 60, and we could go doing that, which would give us 300, and then we have another 60, which gets us to 360, and then I could have another 60, and if I do that I'm going to get 420, and if I do another 60 I'm going to end up with 480, which if you notice 480 is more than what we have. 420 we can actually do. So in that case we're going to have 1, 2, 3, 4, 5, 6, 7 full hours. And if we have 420 minutes, we can count up how many more to get there. 20, 30, 40, 50. We're left with 30 minutes. Now that's obviously a longer way of doing it. Find whichever technique suits you, but the answer comes out to 7 hours and 30 minutes. As I said, you could have done a division, which would have been faster, but I know that not everybody likes doing divisions. On question 8, we have a travel company is taking some passengers on a sea trip. Good for them, that sounds exciting. You can use sailing boats or speedboats. Each sailing boat can carry 41 passengers and each speedboat can carry 7 passengers. The passengers going on the trip would exactly fill 2 sailing boats. If the company uses only speedboats, how many will they need? Well, the key bit of information is here. They can take exactly 2 sailing boats. So if we look at sailing boats, 2 sailing boats would be 41, doubling it because there's 2, means there are 82 passengers in total. Yep. Because they say it could fill 2 sailing boats fully. But the question is, how many speedboats would be needed to do this? Well, like before, you could go counting up 7 plus 7 plus 7 plus 7 until you do it, but in this case that's going to take a little bit too long, so I'm just going to say we had 82 passengers and we're going to divide it into 7 to find out how many groups of 7 we can do. So 7 into 8 fits once, remainder 1. Now we have 7 into 12, which would be 1 because that fits in exactly, and then we'd have to put a decimal place. And what's the remainder? 7, 3, 4, so the remainder is 4. I'm going to add a 0. And again, we can say 7 into 40, and if you did that, you'd end up with an answer coming out as 5, okay? And it would go on, because obviously 5 lots of 7 is 35, and we'd have 5 left over, and you could continue doing this division. But I'm not going to do that. Why? Because I just needed to know how many speedboats they would need. And as you can see, if there were 11 speedboats, it wouldn't be enough because there'd be some remainder left over. So to actually have enough speedboats to carry everybody, we would need a total of 12 speedboats. Yes, there'd be some spare empty places, but at least everybody would get to go on this trip. If you had 11, there'd be some people sitting on the side not able to go. 4 marks for that. Question 9 presents us with a triangle and a straight line. They've marked an angle x here, they've marked this angle here 70, and they've marked that angle there 50. And it says circle the size of the angle x. So one of these is the answer for that x up there. First thing we need to identify is that inside the triangle, all the angles add up to 180. So if I want to find that one, I can do 180, take away these two. So if I add these together, 50 plus 70 is going to be 120. And if I do that, it comes out to 60. So this answer down here, sorry, top there, but down there meaning compared to the x, is 60. So 60 degrees plus 70 plus 50 would give us 180. But that's not what they wanted. They didn't want this, what they wanted the one out there. Now you notice that's on a straight line, and once again, similar to inside and triangle, on a straight line the angles add up to 180. If one of them is 60, the other side will be an obtuse, and 180 take away 60 leaves us with 120. So the answer for this one is 120. 1 mark, so make sure you don't throw it away. Question 10. Paul uses his calculator to work out this calculation. Circle the last digit of the answer. So if you were to calculate this, what would be the last digit? What they mean by that is the one on the right hand side when you do this calculation. So in other words, it's what comes out when you work out that bit there. Okay, so 6 times 4 is 24, so the last digit will be 4. There we are. You don't need to do the full calculation to work that out. Question 11. Now in the exam, hopefully they will provide you with some tracing paper. It makes this question easier, but if you don't have it, a little bit of logic will work just as well. It's a 2-mark question, and they're saying we have here a triangle and we have a point A, and we want whatever we create, we're going to draw something on here so that it has rotational symmetry order 4, and it will be rotated about point A. So when you turn it round around A, it will have order 4. So what I'm going to do is I'm going to say, well, if it's order 4, it means when I do a full rotation, it will have 4 times when it looks the same. So I need to find out what the angle for that. 360 divided by 4 is 90. Okay. So it means every time I turn this round by 90, it will look the same. So if you had a tracing paper, you would draw it, you'd hold it at A, and you'd rotate it by 90 and see what it looked like, and then you rotate it by 90 and see what it looked like. And that's what you would do with tracing paper. I don't have tracing paper, but if I rotated that line there, I would end up with a line coming down here and going along there, and so you'd end up with that. And if you rotate it again by 90, you'd end up with another one coming out on this side, and then you'd end up with another one coming up here. It looks like a windmill. Okay, and the idea is that when you rotate that, there'll be 4 positions when it looks the same. Okay, brilliant. 2 marks. Question 11. Now we're on to question number 12. And in question number 12, they're asking us to work out 23% of 3,500. And to help you, they already tell you what 10% is. 10% of this number is 350. Now, if this were a calculator one, we would just jump in and do 23% of, but because it isn't, we're going to do the one where we break it down. And so we're going to break it down into 1 10%, into a 10%, into a 1%, a 1%, and a 1%. Why am I doing that? Because if I add those all together, I'll end up with the answer, which is 23%, which is what we're after. And they already told us that 10% is 350, so the next 10% will also be 350. When you come to work out 1%, well, to do 1% you basically divide by 100, so divide by 10, divide by 100, and we'll end up with 35. And another 35 here, and another 35 there. And we'll have to add all those together to find out what 23% is. So we have 5, 10, 15, add 1, and here we're going to get 10 plus 1 is 11, 11 plus 3 is 14, 14 plus 3 is 17, 17 plus 3 is 20. Carry 2, 6, because 3 plus 3 is 6, 7, 8, so we're going to end up here with 805. So the answer for this question is 805. Brilliant. Let's move on to question number 13. Question number 13 presents us with a table, and it says Karen records these numbers of lorries boarding the ferry each hour for 24 hours, and here are her results. So those are the number of lorries. She makes this tally and frequency chart, or as I said, table, to record that information. However, don't start jumping in and filling it in, because if you move down here, it says make 2 criticisms of Karen's tally and frequency chart. You do not need to complete the chart. So before you waste any time in completing it, you need to have a little think about what possibly could she have made wrong. By criticisms are like errors or things that she could improve on. Now, there are 2 obvious ones. One of them is, if you look at these numbers, you'll notice there is a 63. We also have a 67. And if you were to try and put it into this table, there is no row. It finishes at 60, so you cannot put 63 or 67 in. So we could write that as one of the criticisms, okay? There is no row for 63 or 67. Or you could say she's missing a last row, or you could say something like the number of lorries does not go up to 67, basically showing that there's a row missing here, yeah, where you could actually put 63 and 67. And the next one is, if you look at what she has here, it says from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, which presents a problem, because if I wanted to put 30 or 20 into this tally, where would I record it? For 30, would I record it here or there? Or the 20, would I record it there or there? So basically, she's gone and repeated it, which means that it's not clear where we can put it. By repeating the 10, we're not sure if we're going to put 10 there or there, etc. for all those. So, if you're very good at writing English, brilliant, write a little sentence explaining it. I'm going to try and explain that there is a repetition in the number of lorries column, e.g., for example, 10 is in the first and second row. Okay, but you could have mentioned any of the others, yes? Brilliant. So something explaining that, for example, 50 appears in both of those. So where do you put 50? Right, let's move on to question number 14. Question number 14 says there are some counters in a bag. They are yellow, green and red. Yellow, green and red. The counter is picked at random. Complete the table. And we're working here with probability. And hopefully you remember that when you add all your probability together, it will come to 1. Okay? So in other words, we can work backwards, because if this plus this plus this equals 1, we could say 1 take away these. So what I'm going to do first is I'm going to add these together. We have 0, 45, 0, 0.3, and if it helps you, call it 30. So when you add those together, you're going to end up with 0.75. Okay, so now when you subtract and you say we have 1, and we're going to take away from 1 0.75. Now hopefully you'll notice that that answer is going to be 0.25, because you should be comfortable with percentages and decimals and stuff. But if you're not, you'd have to do a subtraction, and you say, well, we have 1, take away that, 0 take away, can't do that, so we're going to have to borrow, so there's nothing there. 10, borrow again, so that's 9, 10. 10 take away 5 is 5, 9 take away 7 is 2, dot, 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 and then 0. And you'd end up with the answer nonetheless. But the answer is 0.25. 2 marks for that. Then you move on to question number 15, and question number 15 presents to you a calculation. They have actually done the calculation. 53 times 72 is the same as 3,816, and it says you can use this calculation to help you answer the questions. Now what they mean by that is, if you want to, for each of these calculations down here, you can do the long calculation and you'll get the answer and you'll get the mark. But because there are only 1 mark questions, especially these 2 up here, you can basically use this calculation to save you time and not have to do the full calculation. Why? Because if 53 times 72 equals this number, if we work backwards and do 3,816 divided by 72, the answer will be 53. So working backwards, I can see that I can use that top one there to get the answer. Now obviously you could do the division and get that, but it will take a bit longer. Now once again, it says work out 5.3 times 7.2, which looks remarkably similar to the 53 times 72. So we know that the answer for the digits will look like 3816. But the only difference is, instead of 53 we have 5.3, which means that we have 1 decimal place here. And instead of 72 we have 7.2, which means we have another decimal place there. So if I am to put the decimal places in, we'll go 1, 2, and you'll end up with 38.16. Now for the final question, it's a 2 mark question, and you can do the full calculation if you want to. But what you notice is when you had 53 times 72, you had an answer, and here we have 53 times 73, which means we have another 53 there. So what I could do is I could take the answer for 53 times 72 and then just add another 53 on there, and in that case I would have done 72 lots of 53 here and another 53 there, which would give me 73. So 6 plus 3 is 9, 5 plus 1 is 6, 8 plus nothing is 8, and 3. So the answer for this one would be 3,869. Okay, and I've just written it down there to show. Okay, good. Now we're on to question 16, and question 16 says a security code has 60 characters. It is made up of letters, numbers and symbols, and there's a ratio of letters, numbers and symbols, so we're going to have letters, numbers and symbols, and you need to give it in its simplest form. So what do we know? Well, letters is the first one, number is the second one, and symbols is the third one. They also tell us that there are 30 letters, and we also know there are 12 numbers, and the leftover will be the symbols. So if we had 60 take away 30, we're left with 30, 30 take away 10 is going to be 20, 20 take away 2 is 18, so we have 18 symbols. Okay, 10, 20, 30 and 30 is 60. Now that's good, that would get you a mark, but they also want you to simplify it, so we need to see, and you can do it in steps. You could say half and then you could see what else fits into each of these. But if you're good at your times tables, you'll notice that first of all they all can be divided by 3. Is there anything else? 6 can go in there, 6 can go in there, 6. So what I'm going to do is I'm going to divide all of them by 6. How many 6s fit into 30? 5, because 5 times 6 is 30. How many 6s make 12? Well, 2, because 2 times 6 is 12. And how many 6s make 18? Well, 3, because 3 times 6 is 18. And that's its simplest form. Very good. Question 17 is a fraction question, and they're asking you to calculate it and then give your answer as a mixed number. Once again, there are several ways of doing this, but we want something that's fast. And what I notice is at the moment the denominators are not the same, but what I could do is basically double this denominator to make it 16, because double 8 is 16. So what I'm going to do is I'm going to take the whole fraction and I'm going to double it. In other words, double 7 is 14 and double 8 is 16. The other fraction I'm not going to change. Why? Because it was already 16, and so now my numerators are the same. Sorry, denominators are the same. So we can then keep it and we can do our calculation. 14 plus 9 is going to be 23. Okay. So that's all good. We've got the answer. However, that's not a mixed number, that's an improper fraction. So a mixed number, you say how many 16s fit into 23? 1. What's the remainder? Well, if we have 1 16, 17, 18, 19, 20, 21, 22, 23, we have a remainder of 7. And we were talking about 16s. Okay, so 16 and 7 would be 23, so that's fine. And then we'll just write our answer down here. It's going to be 1 and 7 lots of 16. Brilliant. Let's have a look at question number 18. And 18 is one of those questions that spans 2 pages. See 18, 18A down there, 18B, 18C. So you just have to keep that in mind when you do this question. They tell us that the cost of renting a storage unit is a fixed charge and a charge per month. The cost of renting the storage unit for 5 months is shown in this graph, and you can see here 1, 2, 3, 4, 5 months, and the cost in pounds. Now the fixed charge is the amount that you have to pay regardless of how long you actually rent it for. So in other words, is what is the starting bit. And you can see here that doesn't matter how much you rent it for, you always have to pay £40. And that is your fixed charge. So here we can say £40 is the fixed charge. Then we move on to part B, and part B says work out the charge per month. So we want to know how much they charge for each month. So we want to be able to read the graph clearly to get this information, and I'm going to go all the way here, and the reason for that is that 5 months is a nice number, it's 120, but if I try to use 4, I'm going to have to count and see what that is, which is fine, you can do that, and 3 you have to count what that is, and 2 you have to count what it is, and 1 you have to count what it is, which is fine. You're very welcome to do that. And in fact, if you were to do that, it's actually quite easy. But in this case, I'm just being lazy and I'm thinking, you know what? I can read that when it's 5 months, it's 120. So one method would be to say, well, we know it started off at 40. How much more do they charge for 5 months? Because it's from there going up to there. So from there to there. So we had 20, 40, 60, 80. So they charge £80 for 5 months. So if I divide it by 5, it will tell me how much they charge for 1 month. And if I divide 80 by 5, I end up with 16. Okay, if you're not sure, you can just do 80. 5. Does 5 fit into 8? Yes, it does once. What's left over? 3. Does 5 fit into 30? Yes, it does 6 times. And there's no remainder. So £16 is what they charge per month. Okay, so down here we can write 16. Now, if you didn't like doing that, you could have just counted up and you said, well, here it was £40 and here how much more, and you only have to work out how much each of these little boxes is worth. And to do that, you notice that's 20. So 20 divided by 5 boxes would be 4. So each box is 4. So you'd basically go 4, 8, 12, 16, 20. So here you would have gone 4, 8, 12, 16, and you would have had the same answer as we did doing it that way. You then move on to question number 18C, and it says work out the cost of renting the storage unit for 7 months. So we know that whatever happens, they're going to have to pay £40 because that's a fixed charge, and they will have to add to that 7 lots of 16, because if they rent it for 6 months, they have to pay £16 for every month, and then they have to add 40 onto it. Okay, so if we work at this bit first, because in order operation we always do multiplication before addition, so we could say how many 7 times 6 is 42, carry 4, 7 times 1 is 7, plus the 4 that we had is 112. And when you add these together, 112, you're going to end up with £152 is what it will cost you for 7 months. Very good. So now you are progressing, or we're on to question number 19. And I hope you realise that as you go through these papers, different questions will suit you better than others, and it just depends on how what you're familiar with, but also how your brain works. So some of them will be nicer for you than others, and it's just the way it is. Here we have a company, and they sell boxes of bolts and boxes of washers. Here's the bolts, here's the washers, and they tell us here are 11 boxes, and they've counted what's inside them. So one box has 65, one box has 60, one box has 67, and over here for the washers they had 10 boxes, and one of them has 56 in them, and another one has like 58 in them. The company claims that the average item per box is at least 60, so in other words 60 or more. Okay. Using medians in the company, is the company claim correct for each of the items? So we're going to have to work out the median. They tell you must work out the median for the bolts and the median for washers, so you can't get around it, you're going to have to do it. So we're going to work out with the bolts. Now the first thing we need to do is put them in order. Okay, so what we're looking for, the smallest there, 60, there's a 59, there's a 57 and a 59. So we're going to have a 57, we have a 59, we had another 59 here. After that there's a 60. Any other 60s? Yes, there's another 60 there. After 60 there's a 61. After 61 we're looking for the smallest one, there's a 64. After 64 we see there's a 65, actually there's several 65s, there's one there, there's a second one, and there's a third one, and at the very end we have a 67. They tell us there's 11, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we want to find a median, and to find a median you need the middle one, so 1 on each side, 2 on each side, 3 on each side, 4 on each side, 5 on each side, and so the answer comes out to 61. And the question is it at least 60? Well, 61 is more than 60, so the answer is yes for the bolts. Now we're going to do exactly the same thing for the washers. We're going to put them in order, and in this case the smallest number we're starting with 58, 58, 57, 50. Have they been nice enough to put them in order? Let's see, 56, 57, 58, 58, 60, 63. Yes, so they're already in order, so we don't have to put them in order. So now we can just find the middle one. 1, 2, 3, 4. But the middle one is going to be there. So we need to be in the middle of 58 and 50 and 60. Now you might spot that it's going to be 59, because 59 is in the middle of 58 and 60. But if you're not sure about that, you could add 58 to 60 and then divide by 2 and you'll get 59. And 59 is not at least 60. So in this case we're going to tick the answer no, it isn't. That was actually quite nice, even though it looked very long to start with. We're on to question number 20. And question number 20, Firos tries to work out this calculation. His answer is 14.92. By rounding each of the numbers to the nearest 10, show that his answer is incorrect. Okay, so we have 39.17. If we round up to the nearest 10, it's going to be 40. Then we're going to add it. 76.78. If we round up to the nearest 10, that's going to be 80. And at the bottom, we have 19.84, which will round to 20. That will get you a mark. We then need to calculate, so we're going to say 40 plus 180 is going to be 120. Divide by 20. Okay. And you can count up how many 20s fit into 120, or we could cancel some zeros. And how many 2s are in 12? 6. So in this case, as an approximation, the answer comes out to 6. He said it was 14.92, which, as you can see, is not close. Okay, so in this case we've shown that it's not there. Let's move down to question 21, and question 21 is parallel lines. So you have two parallel lines. They've marked this angle here as x. Down here they have A, B, C and D, and they're asking for the alternate angle that is the alternate angles to x. So for that, what you need to do is you need to be inside the parallel lines, which means it's either going to be A and B, and alternate means it's on the other side, so it's going to be x and A. But the other thing to notice is if you were comparing those, you're looking for the acute angle, because that's acute and that was an acute one. B would be an obtuse, so they wouldn't match. So in that case, x, the alternate to that is going to be a. Okay. Question 22a. Jackie wants to simplify, and they have 7p, take away 5q, take away 3p, but notice there's a bracket. So really what we're doing is we have 7p and we're taking away everything inside the bracket. And she writes 4p plus 5q, and we have to say, is she correct? Tick a box and give a reason. Well, if we actually try and do her calculation, sorry, let me bring it back down so you can see, we would actually have 7p take away, if I remove the bracket, 5q, because we're taking everything away from bracket, take away 3p, yeah, because you're taking away and a take away here, so we have minus minus. Okay, so if we did that, when you actually came to work that one out, that would be like adding. So we'd actually have 7p plus 3p, which would give us 10p, and there's nothing we can do with the 5q, so we just leave it there as 5q. So let's see what she did and what we've worked out, and you can see the last bit's correct, but the first bit isn't, so no, she's not correct. Okay. We move down here, and Jackie is trying to do a different calculation this time. She has one with powers, and she says if we have 4a cubed times 7a to the power of 5, she says you can multiply the 4 and the 7, and then multiply the 5, the 3 and the 5, and her answer is 28a15. Tick a box for each part of a method. Now, multiplying the 4 and 7 is absolutely correct because the multiplication, yes, we have a multiplication, so 4 times 7 is going to be 28, so that's fine. But the second bit is not correct, because when you come to multiplying bases that are the same, you can add the powers. So what you should actually have is 8 plus 5 to get a to the power of 8. So she is wrong. 22c, and 22c is a calculation, a bit kind of like problem solving type question, because it says 20 lots of something. So you do 20 lots of something would be give you the same answer as 80 divided by something, but they're telling us give a possible value of the number. So in other words, what I put in this box will have to be the same number, and it tells me that what I calculate on that side will give me the same as that side. So it's a bit of trial and error. You could try things out. So you could put a 1 in here. 20 times 1 would be 20. 80 divided by 20, that wouldn't work because you end up with 1 times 20 is 20, and 80 divided by 1 is 80, and it's not the same. So you could try something else like 2. So if you ended up putting a 2 in there, you'd have 20 times 2, which would give me 40 on this side. And if I put a 2 in here, 80, half of 80 is 40. And if you did that, you can see the left hand side and the right hand side are the same. So one of the possible answers is 2. Okay. But you could try other ones and see what else worked. Right. What else do we need to do? Let's move down to question number 23. And question 23 says Adam's age is 3 years and 6 months. Zara's age is 2 years and 11 months. Write Adam's age in months as a fraction of Zara's age in months. So we're going to have to change it to months, and then we're going to have to give our answer in its simplest form. So if we look at Adam is 3 years old, and each year is 12 months. So 3 lots of 12 is 36. And he has another 6 months, so we then have 36 plus another 6 will give us 42. So that's Adam. If you want that to remind yourself, say that's Adam. Now we're going to work out Zara, and Zara's is 2 years, so we're going to have 2 lots of 12 to get 24, and then she has 11 months, so we're going to have 24 plus 11, which should give us 35. And it says write Adam's age as a fraction of Zara's. So Adam will be on top on this one, and on the bottom we'll have Zara. So that's okay, that would get you 1 mark, but we now need to simplify it. So we're looking to see what we can do. Now I can't halve it because I can halve 42, but I can't halve 35 because 5 is an odd number. So we're trying to think, well, what else? So if I spot that the bottom one is 5 lots of 7, because 5 times 7 is 35. So I'm going to now check Can I divide the top one by 5? No, I can't, because it ends in a 2, not a 0 or 5. So can I divide by 7? How many 7s make 42? And you'll notice 6 lots of 7 is 42. So I could cancel the 7s, and I can end up here with 6 out of 5 being the answer for question number 23. Beautiful. Let's have a look at the next bit. The next bit is question 24. And question 24, working alone, it takes Kai 3 hours to concrete an area of 8 meters squared. Kai and Jade are going to concrete an area of 24 meters squared. Jade says, working together at the same rate, it will take us 9 hours because 24 is 3 times 8. So in other words, 3 lots of 8, 24, so 3 lots of 3 hours will be 9. Is he correct? Tick a box. Now, on the face of it, it sounds nice because they're saying if you look at the meters squared, instead of doing 8, they're going to do 24, which means it's tripled because 3 times 8 is 24. So if we're looking at the hours, the time it took, before it took 3, and now we're going to triple it, and if we triple it we get 9, and so that makes it look like it's correct. But that's if we just had Kai doing the job, then it would be correct. But we no longer have Kai doing the job, we have Kai and we have Jade doing the job, so they actually can split the work between them and you can do it faster, can't they? So the answer is going to be no, and the reason is because there are now 2 people to do the job or the task. Okay, so it's going to take half the time, so it will take half of 9, so it would take 4.5 hours. Okay, because if there's 2 people, they can split the work between them, can't they? We're now on to 25, and it says solve this inequality. So what we need to do is we need to collect all the x's on one side, and we need to collect all our just our values, the integers on the other side. Okay, so I look and I have 7x there and 5x there. So if I want to keep this balanced, I'm going to remove the 5x from this side. How? By taking it away, which means I'm going to also have to remove it from the left hand side. 5x, take away 5x is removed, and it will just leave me with a 10 on the right hand side. And here I have 7x, take away 5x, which will leave me with 2x. But I still have the plus 3 here. Okay, so now I want to collect these ones on the other side. So how do I do that? I'm going to remove the 3 from the left hand side, so I'm going to remove it from the right hand side. So 3 take away 3 disappear, and I'm just left with 2x. And here I have 10 take away 3 is 7. And the last bit is to remove the 2 from this one. I need to divide, because divide is the opposite of multiplying. I need to do it on the left and the right hand side to cancel to get the x. And so we end up with x is greater than 7 over 2. Now they didn't ask us to give it as a fraction or anything, so you could leave it like that, but if you wanted to, you could change it as a decimal and have it as 3.5, but I'm just going to leave it like that. So x is bigger than 7 over 2. Okay, let's make that one a bit more clear what I'm intend by that. There we are, make it nice and obvious. Brilliant. Question 25b has an inequality. Now these are actually quite nice to write because we can see where it starts. It starts at 1, it finishes at 6. We have, this is the number line, it's x, so the x values that are allowed are between 1 and 6. And x is bigger than 1 but it's smaller than 6. This is open, so this stays as an inequality, there's no equals, and here it's included, so we can put the equals bit there. There you are, 2 marks for that. Now question 26 is a little bit more of a tricky one. It might you might enjoy it, or it might just confuse you, so it depends on how your mind works as to whether you like it or not. So we're going to work through it, and then you decide if you'd like to try it or not yourself. So what we have is we have a combination of an x and a y-axis, and that's that faint grey one, okay, and the origin is marked as that O. Then we also have these dashed lines, and the dashed line is y equals 4 line, and this dashed line here is x equals 2 line. And they've marked, or they've drawn an octagon, and they've marked this vertex or this corner of the octagon down here, and they've labelled it as -3, -4, 5 as their coordinates. They've got B marked up there, and they tell us that lines x equals 2 and y equals 4 are lines of symmetry. So in other words, if I fold that shape, that side will be the same as that side, and if I fold along there, the top will be the same as the bottom. Work out the coordinates of B. So first things first, we need to understand what's happening. If this is a line of symmetry, it means that this distance on that side will be the same as the distance on this side, because symmetry line means the fold will be equally distant. Okay, why am I trying to get to this one? Because that's where B is. Okay, same idea. If you look here, and we have the mirror line, the distance from going from there, B, to the mirror line will be the same as the distance from the mirror line down here. Okay, because those distances will be equal to each other. I'll just put some arrows on so that we can see which ones we're talking about. Okay, so I'm going to have to find what that distance is, and then I can basically, if I know the distance on this side, I can add it to that side. Okay, what do I know? Well, these coordinates are not going from this line, they're going from the origin, from the y-axis. And so when it says here -3, it's telling me that this jump here is worth 3, because we go from 0 to -3, so it's a jump of 3. And this is a line equals x equals 2, which tells me this jump there is 2. So the full distance from the symmetry line to that side is a jump of 5, because 3 plus 2 is 5, which tells me that the jump going from there to there will also be 5. 5 on the left, 5 on the right. However, when I come to do the actual coordinate, I'm not going to write 5. Why? Because 5 is from this line here, but the actual x-axis starts from y equals 0 and it goes along here. So if I have that, I have 2 plus 5, 7. So the coordinate is actually going to be 7 for B in the x direction. And now we think similarly for the in the y direction. What do we know? Well, going from the x-axis down, they told us that this jump here is 5, because this is -5, so if this is 0, it goes down 5. This line is called 4, which means that this bit here is worth 4. So going from that line of symmetry down is a jump of 9, which means if we go up, the jump is going to be 9. Why 9? Because 5 plus 4 is 9. But once again, I'm not going to put 9 as my coordinate, because the coordinate starts from the x-axis. So we had 4 plus 9 is 13. So when we do that, the actual coordinate will come out to 13. Bit tricky, as I said, it either suits you or it doesn't, that type of question. But you might have a little think about it and have a go at it. You're now on to question 27a and b, and you'll notice that they are the standard form questions. And in this case, they're asking us to work out the calculation. So you can do 3 times 6. If you do 3 times 6, you get 18. And then here you have 1, 2, 3 zeros, 1, 2, 3 zeros, and here you have 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros. So that's the calculation that would get you a mark. But they don't want it as ordinary, they want it in standard form. So in standard form, we'll have 1.8 times 10. It's a large number, so it's going to be a positive power. And here we had no decimal point, which means it's moved 1 space, 2 spaces, 3, 4, 5, 6, 7, 8 to get there. So the answer for this one is going to be 1.8. Let me bring it into view. 1.8 times 10 to the power of 8. Then when you come to question B, they give us a calculation and it's in standard form, and they said give your answer in ordinary form. So we're going to change them to ordinary and then we'll do the calculation. So if you change 2.1 times 10 to the 3, it's going to get bigger because it's going to be a bigger number. 10 to the power 3 is 1,000. So if I multiply this by 1,000, I'll have 10, 100, 1,000. So I'll end up with an answer which is 2,100. 100. Let's make it look more like 1,000. Okay, and here when we have 3, it's a negative power, so it's going to get smaller. In other words, we're going to divide by 100. Why? Because 10 squared is 100, so we're going to divide by 10, we're going to divide by 100, and we end up with 0.3. So we're going to basically divide by 0.03. So all I've done is I've changed those numbers into normal numbers. Dividing is not very nice, or writing it as a fraction is not very nice if it's a decimal. So what we can do is we can do the equivalent fraction. So what I'm going to do is I'm going to multiply this one by 100. I multiply that one by 100. Why? Because I'm going to multiply this one by 100 and it was it moving there. So I'm going to get on the bottom of 3. And on top I end up with 2,100 times by 100 to get that answer. You might say, oh, well, that's no good. But yes, it is, because 21 can be divided by 3. How many 3's in 21? 7. And then we have all those zeros. So the answer for this one would come out to 7. 1, 2, 3, 4 zeros. So we have 70,000. So we can write here 70,000 for that answer. Very well done for getting this far. We're getting close to the end. We're now on question 28. In question 28, when you first look at it, you might think, oh, I'm not sure about this, but it actually is rather nice if you have the patience to just work through it. They tell us that the distance from C to D, so from here to there, is twice the distance of A to B. So whatever this distance is, this one here is twice. They also tell us that the distance from B to C is 4. So between B and C is 4 kilometers. So that distance we know. Okay. She then runs. She runs from A to C. And when she runs from A to C, she runs for half an hour. 30 minutes is half an hour. At an average speed of 14 kilometers per hour. Now, understand what that means. That means that if she runs for a full hour, she will cover 14 kilometers. But here we know that she doesn't do an hour, she does half an hour. So if I split that in half, instead of having 14, we'd have 7. So she's actually going to be running for 7. So in 30 minutes, she runs for 7 kilometers. What's that 7 kilometers means? Where does it go from? Well, it goes from A to C. So if you start from A all the way to C, is 7 kilometers. You might say, well, why does that help? Well, here we knew it's 4, and from there to there is 7, so that helps me work out what this bit is, and that's going to be 3, because 3 plus 4 is 7, or 7 take away 4 is 3. And if this bit is 3, it helps me find that one, because the distance from C to D is double the distance from A to B. So if this one is 3, this bit here is 6. And what did the question say? It said work out the distance from A to D, going from A all the way to D. So if you did that, we know that A to C is 7 plus another 6. So we can have 7 plus 6, and if you did that, it's going to come out to 13. Or you could do 3 plus 4 is 7, 7 plus 6, 13. It's up to you, but the answer for this one says that basically the distance from A to D is 13 kilometers. It's actually quite a nice question. Question 29 has a graph plotted, and they have different equations, and they're just asking to see which is the equation that fits. Now, to do that, just test some values. So if I choose, for example, x equals 0, and I substitute it in here, that gives me that y comes out as 0, which means that there'll be the line would go through the origin, and it doesn't even touch it, so that's no good. In this case here, if I substitute x equals 0 in there, I'm going to get 0 plus 1, y comes out to 1. So when x is 0, y comes out to 1. So it's going to go through the point 0, and it's going to cross through 1. But notice it doesn't cross the y-axis at all. And yet this would say that when x is 0, it would cross here at 1 somewhere. So again, no good. Okay. On this one here, if I put in there, I put x equals 0. 1 divided by 0, well, if you divide by 0, it actually is undefined. We don't know what it is, which kind of makes sense because you're trying to divide by something that's 0 and it's not going to work. It's going to be, so we'll come back to that one in a moment. Let's try here. Put x equals 0 in there. I put 0 in there, y will come out as 1. and that doesn't work for the same reasons as we said that this curve doesn't go through the point 0, 1. So on the face of it, it looks like that one, but you could also use a bit of logic. If x is very big, you put a big number down here, 1 divided by a big number, the answer would come out as y equals small. And indeed, as x gets bigger, y is getting smaller and smaller and smaller. If x was small, so I divide 1 by a small number, I'm going to get a big answer coming out. So y will be big. And if you notice, when x gets smaller, y gets bigger. So it does actually fit quite nicely. Okay. Question 30 is one of those standard questions that you should be very familiar with by now. It says write 360 as a product of prime factors, give your answer in index form. So the first thing we need to do is break down 360 into its prime factors. And it's kind of an easy one to do because that's 36 times 10 would be 360. There are other ways of doing it. And then you think, well, 36 would be 6 times 6. And 6 can be broken down into 2 times 3. And again, this 6 here can be broken down into 2 times 3. And these are primes. 2 is prime, 3 is prime, 2 is prime, 3 is prime. So 2 times 3 is 6, 2 times 3 is 6, 6 times 6 is 36. So now we have to do the same for 10, and 10 can be broken down into 2 and 5, and 2 is prime and 5 is prime. So if we were just writing 360 as a product of its primes, we say 2 times 2 times 2, because there's 2, 2, 2, and then we say times by 3 because there's 3 and 3, and at the very end we say times by 5. But they didn't want that, they want it as index form. So when you come to do that, we would say 360 is 2 to the power of 1, 2, 3 times 3 to the power of 2, because there's 2 of them, times by 5, and that would get you the full 3 marks. Very nice. So you're on to the last page. Well done for making it this far. Question 31 is a trigonometric question. Now with trigonometry, you kind of need to remember certain, especially with the non-calculator version, certain what they call exact values, or you kind of just need to know what they are. So things like for 30, angle of 30, angle of 60, and angle of 45. So they said use trigonometry to find x. So if we label it, that's our angle. So this one's my opposite. This one's the hypotenuse. So need something that has opposite and hypotenuse. So hopefully you remember that that will be sine. Sine 30. Opposite. Opposite would be 8 divided by the hypotenuse. Okay, so that's the one we would use. And this way you need to remember that sine 30 is actually a half. So in other words, that would be a half equals 8 over hypotenuse. And we are looking for the hypotenuse. Hypotenuse is the x that we want. Okay? And so to do that, we'd actually have to do hypotenuse is equal to 8 divided by 0.5. Okay? We're rearranging it, and what we have is if you 8 divided by the hypotenuse would give you a half. In other words, the hypotenuse would be 8 divided by a half. And if you say how many halves are in 8, you'd end up with 16. So the answer for this one is that the hypotenuse, or x, is equal to 16. But as I said, this is slightly more advanced, so if you're familiar and you're happy to work with trigonometry, and not only that, but to know the exact solutions, then you're fine. Otherwise, perhaps getting as far as that would be a good point to do. Okay. Now, obviously, what they were asking for was for x, so you might actually, instead of writing h there, you might write x all along. And again, this one here might be an x, and that one there might be an x. It's up to you what you feel more comfortable with. And then we're on to the last one, and the last one's factorize. Now it's a quadratic, and you'll notice that factorize is when we need to put the brackets in, but because it's one of these quadratics, it's spotting that it's actually going to be 2 brackets. So that's what it's going to look like, our factorization. So I can write my 2 brackets down there, knowing that that's where I'm going. And so to do that, that x squared would come from x times x. So that's quite easy to work out. X times x would give us x squared. However, now comes a bit where you have to use a little bit of logic or breaking it down. We're looking for 2 numbers that when we add them, give the answer 10, and those same two numbers, when you multiply them together, give you 21. This is where it helps knowing your times tables, because you'll notice that 21 is 3 lots of 7, but you'll also notice that 3 plus 7 is 10. So what we're going to have here is 3 and 7. So when we write down our answer, we're going to have a plus 3 and a plus 7. And that's it. So very well done for getting this far. Hopefully I haven't made any mistakes, but please let me know if I have. Have a lovely evening. Bye-bye.